Day 5. Aim, how many electrons are in each principal energy level? All right, click pause and attempt to do the 3 questions below. Okay, we're back. Here we go. It says, which electron configuration represents the electrons of an atom of chlorine in the excited state? Well, on table S, if you don't know which symbol chlorine is, on table S it tells you it's Cl. And what you need to look up on your periodic table is the atomic number of chlorine. The atomic number of chlorine is 17, while the mass says there is 35. Okay. It says, write the excited state of chlorine. Okay. So the excited state of chlorine, first of all, we need to look up the ground state on the periodic table. The ground state says 2-8-7. Now, we learned yesterday that when an electron becomes excited, it must absorb energy to jump up to a higher level. So it usually jumps from the second to last to last. In this case, it'll jump from the second to third. So if one electron jumps up from the second to the third here, our excited state configuration will now become 2-7-8. Okay, let's move on. Diagram below represents the nucleus of an atom. So now, it says here, what are the atomic number and mass number of this atom? Well, we learned that the atomic number are the number of protons. And we learned that the mass number are both protons and neutrons. Now, protons are represented by the black circle, while neutrons are the white circle. So it says, what's the atomic number, mass, and number of this atom? Well, let's count the number of black circles for protons. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the atomic number is 9. Okay, so it can't be choice 3 or 4. Mass number, well, we just said the mass, the atomic mass and mass number are the protons plus the neutrons. So we have 9 protons plus, well, let's count the white circles now to see how many neutrons we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Okay? So 9 plus 11 will give me 20. Okay? So the answer is going to simply be choice 2. Moving on. Which diagram represents the nucleus of an atom? Okay, well, what do we learn, guys? We learned that the nucleus are the protons and the neutrons. Electrons are not located in the nucleus. They're outside the nucleus, orbiting around. So the atomic number tells me the number of protons. So it's 13 protons. If you subtract them, that tells me the number of neutrons. So the answer should have 13 protons and 14 neutrons. Choice 2. Okay. Let's move on to the next slide here, all right? Let's first go to our periodic table. I'd like to access that and show you basically what's going on here. So again, the top number is your mass. In this case for carbon, 12.011. We're going to simply round it up to 12. The atomic number is 6. The electron configuration here is 2-4. And we learned yesterday that the 2 electrons represents the number of electrons in the first level of shell. 4 represents how many electrons in the second level of shell. Okay. So let's go back over here for a second. Let's go back to the slide, all right? All right. Number says here, group 1, what is the common theme for each level of shell? Well, if you look over here, what is the maximum number of electrons that the first level of shell can hold? The first level of shell is simply the first set of numbers. Well, the maximum number of electrons in the first level of shell, if you notice, does not get larger than 2. So the first shell holds 2 electrons. And we're going to fill this in the next slide, guys. Look at the second level of shell. The second level of shell holds a maximum of how many electrons? Well, second hold, the largest it becomes, is 8 electrons. The third level or shell are the third set of numbers. The maximum that number becomes is 18. So the third holds 18 electrons. While the fourth level of shell are these set of numbers here. The largest that becomes is 32. All right? Now, we know that because you can simply look it up over here. If you notice, guys, I went down group 1. So let me show you the actual periodic table what I'm talking about here. All right? So, let's go to group 1. All right? Here is group 1 over here. See what it says here? Groups. That's a group. This is group 1. Group 1 also is including this element, hydrogen, as well. Now, if you notice over here, the electron configuration hydrogen is 1, 2-1, 281, 2881, 281881, 2818, Now, over here, if you notice, there's something missing here, guys. What's missing here are the 2-8. They did not include that here because of the fact there's not enough space in the box. But just know it's there. So if you ever want to know what's the maximum number of electrons in each level or shell for any given element, you just simply look on the periodic table here. Okay? And the first level of shell, we said, has 2. The second has 8. The third is 18. And the fourth holds 32. So it's all given to you right there. All right? All right, let's move on here. So let's fill up right now what it says here. All right? First, the slide over here, number 10. Principal energy levels of shells and how many electrons? Well, hit pause and right now fill this in. Okay, we're back. So basically we said before, the first level of shell holds 2 electrons. Okay? The second level of shell holds 8 electrons, while the third holds 18, and the maximum number of electrons in the fourth level or shell holds 32. So again, guys, simply go to FR. FR, remember, you need to fill this in so you know. It's 2-8, that's not there on the periodic table. You need to add that in. -18-32. So it tells you how many in each level of shell. Okay, let's move on. That's the maximum each one can hold, all right? Here we go. Principal energy level questions over here. Okay. So it says, how many occupied principal energy levels are in selenium? Well, guys, if you look over here, selenium, I gave it to you, the electron, the ground state configuration here. How many are occupied? Well, let's see. Well, there's 2 in the first. There's 8 in the second. There's 18 in the third shell or level. There's 6 in the fourth shell or level. So how many occupied here? Well, how many have at least 1 electron? Well, if you notice, there's 4 numbers here. So this simply are 4 occupied levels or shells. Okay? So understand what that wording means. Occupied simply means there's something in there. Now, the next question, however, says, how many are filled? Now, filled means the max it can hold, right? So we just went over that before, guys. All right, we said the max the first one can hold is 2. The max the second level or a shell can hold is 8. The max the third one can hold is 18. Now, what was the max the fourth can hold? Well, the fourth one can hold up to 32. This only has 6 here. So the question is this one filled? No, because it can hold to 32. So how many are filled? Well, if you notice, the first, second, and third are filled. The fourth is not. So there's only 3 that are filled. Okay? Again, the fourth holds a max of 32. This only has 6 electrons there. So it's not filled. Next, this 2-8-18-6 represent the excited ground state. Well, guys, if you go to your periodic table, you'll notice for selenium, it says 2-8-18-6. Remember what we said, if you look up the electron configuration on the periodic table, that represents the ground state. So ground state is your answer there. Now, if it said to you, write the excited state configuration. So if we're going to write, let's say, exciting state configuration of this guy, of this, it would end up being 2, 8, 17, 7. Because we learned, remember we said that one of the electrons here will jump from the second to the last level. Okay? All right, it says, which principal energy level or shell is partially filled in P, in phosphorus? All right, hit pause and look up phosphorus yourself right now and write down the ground state configuration. Okay, we're back. So phosphorus says on the periodic table, the ground state is 285. So let's see, what do we say again? Well, the first one holds a maximum of 2, so that's filled. The second level shell holds a maximum of 8. That's filled. The third holds a max of 18. So is the third one filled or partially filled? That's right. The third one is partially filled. So the answer is a third shell or level is partially filled. Okay? All right, let's move on. This is like a funny little clip where people are just basically slingshotting themselves back and forth here. Okay. Distance from nucleus. Okay. Distance from nucleus and energy. All right, guys, let's think of a rubber band. All right. I want to look at this picture down here. It reminds you a little bit of a rubber band. But this is a picture of the atom. Right? We said the nucleus is in the middle, which has the protons and the neutrons, right? And that's what gives it a positive charge. While the electrons are in these blue dots outside, all right? So now, let's count the levels here. This is the first level. You notice? That is the second. That is the third. And this is the fourth level. So let's think of a rubber band, all right? If you ever, strike someone with a rubber band, you'll notice that the rubber band will hurt them more the further you stretch it. Similar to which electron has more energy. Well, let's think a second. If an electron is in the first shell, that's pretty close to the nucleus here. You notice that's pretty close. So it hasn't been stretched that much. While an electron in the fourth shell or level is pretty far away. So think, if you're stretching that rubber band all the way out to the fourth shell, you're going to have a lot more energy behind that rubber band as you would in the first shell. So this brings us to what we're going to learn now. Distance from the nucleus affects the energy. So we said, the closer you are to the nucleus of an atom, the less energy an electron has. Makes sense. Okay. So who has more energy? An electron in the first or the third shell? Well, the further away you are from the nucleus, the more energy you have. So here's the example. The fourth level or shell has more energy than the third level or shell, right? Well, isn't the fourth one further away than the third one? Here is a third. There is the fourth. So the further away you are from the nucleus, the more energy you have, okay? Okay, let's move on. Okay, let's go over here now to, I want to get off of this slide. Let's go over to PDF here, homework, all right? Hit pause and try these yourself. Okay, we're back. Compared to the energy of an electron in the second shell, all right, it says the energy of an electron in electron of sulfur, the energy of an electron, okay, so what happens now? Compared to the second shell, sulfur, energy of electron in the first shell, is it higher or lower? Well, it's lower, we said, because of the fact it's closer to the nucleus. Number 2, which statement describes the relative energy of the electrons in shells of a calcium atom? What do we say? The further away you are, the more energy you have. So A says electron in the first shell is more energy than the second shell? No. Electron in the first shell is the same amount of energy as the second shell? No. Electron in the third shell has more energy than the second shell. Well, that is correct. Number 3. The electron configuration of an atom, the ground state is 2-4. The total number of occupied principal energy levels atom are, well, how many are occupied here, guys? Well, we are occupying 1, 2 levels of shells. So the answer is simply 2. Number 4, what is the maximum number of electrons that can occupy the 4th principal energy level? Guys, we said the first holds 2. The second holds 8. You go to FR, right? Bottom left corner of the table, time number 87. The third holds 18. And the fourth holds a maximum of 32. You don't need to memorize this. Go to the table, your periodic tables, guys. Remember, FR 2-8 is not there. You must put it in there. 5, what is the highest principal energy level for an electron atom of sulfur in the ground state? Hit pause and find sulfur in your periodic table and write down the electron configuration. Okay, we're back. 286. That is the electron configuration of sulfur. So what's the highest level? Well, we have the first level, second. The highest would be the third level there. All right, let's just do this page over here. Number 8. What is the maximum electrons present in the second principal energy level of an atom? We said 2, 8, 18, 32. So the second holds a maximum of 8. Let's finish this worksheet off here. Last question, number 9. Compare the energy of an electron in the first shell to the energy of an electron in the second shell. Well, what do we say, guys? The further away you are from the nucleus, the more or less energy do you have? Well, further away you are, the more energy. So compare the energy. Who has more energy, the first or second? You can say second has more energy than the first. Or you can say the first has less energy than the second. Either one will be fine. All right.